All right, welcome back everyone. Good morning. So today we're going to be learning about Django-ORM. So to put this in kind of perspective, a little background about what problem we're trying to solve here. So, recently we learned how to query PostgreSQL, which stores its data in relational tables. Relational tables, that's what we call it, and a SQL database, and we have multiple tables that relate to each other. These are called relational databases. That's in that acronym RDBMS, Relational Database Management System. So Postgres stores data in relational tables. Now, before that, as you may recall, we've been learning about Django and Python more generally, which store their data in Python objects. So these are both very useful ways to store and manipulate data, but unfortunately, it makes it a little bit tricky for us to write a Python application that queries a SQL database because these are different formats for storing data. There's just different rules about how you interact with them. So what we need is a piece of software that helps us create a mapping between relational tables and objects. So such a software tool is called an object relational mapper. So again, the reason why we use ORMs is because the data is stored in relational tables in raw SQL, but our application is working with Python objects. And so we're going to use the object relational mapper to create a mapping between our tables and our objects. So it's going to let us work with our SQL data in Python. So oftentimes an ORM is like a separate component that you have to install individually. But fortunately, Django includes its own ORM that's custom built to work just with Django. So it integrates very well. This is honestly the best ORM I've ever seen. I think it's a really impressive piece of technology, and it's probably my favorite part of Django. So now that we're using it, we're not going to write raw SQL anymore. And so instead, what we do is we define classes, which are called models, from which Django-ORM automatically creates tables in Postgres. And then we're going to use instances of these classes to represent individual rows of our tables. So that's kind of the main feature of what an ORM does, is just translating between our tables and our objects. There are some other useful features, though, that an ORM can provide for you, such as help us manage changes to our database schema, which are known as migrations. So this is actually kind of a tough problem to solve well. So I really appreciate that Django helps us out with this a lot. So that's really all of the theory that I want to talk about. I'm ready to just start writing some code, building an app. But does anyone have any questions just about what the heck we're doing today? What is an ORM? Why do we care? just anything about databases in general before we move forward.
Are we going to learn how to do this for a shopping app right now? For an e-commerce app?
No, I think school attendance is the theme for today's demo. So not quite the same as the assessment, sorry. Any other last minute questions before we dive in and get started? All right, guess not. So let's build an app. So first thing I need to do is create a virtual environment. I can't install any dependencies without a virtual environment. So we'll say utility slash, oh wait, no. So Python -m venv, utility slash venvs, and we're going to call this school env, because we're making an application for a school, helps us take attendance for the students. Cool. So now I will activate it. Great. So now I can see the command prompt change. So I know I'm in my virtual environment. So now I've done that, I will install Django. Hopefully these steps are becoming familiar after a while as I'm doing this repeatedly. So now that I've installed Django, I can use Django to scaffold an application. All right, got my school project. I'm gonna go inside of there. So there's still like more app setup stuff I could do, but right now I want to focus more on the database setup. So we're going to kind of switch gears. So I want to use a database called school for my school project. And I actually can't create that in Django. I have to create that just any other way. And then Django can connect to an existing database. All right, so first I'm going to connect to Postgres using pSQL. I'm just going to connect to the default database. That's just called Postgres. Everyone, when you installed Postgres, it came with a default database named Postgres. So if you need to connect somewhere, don't know what to connect to, this is just the default option that already exists. But now the first thing I'm going to do here is actually just create a different database. We're going to call it school. Can't forget my semicolon. Great. So I create the database. I do /l. You can see here is my school database. So that's great. Now I'm not going to actually define any tables here or the schema for anything. That can all happen within Django. I just need to create the database itself at the command line. All right, so now, so before we get too much further in this, I need to install a dependency. So Django-ORM doesn't actually come included with everything it needs to run. There's yet another library that Django-ORM depends on, and we have to install this separately. So I'm just going to exit out of pSQL here. I'm still in my school environment, so that's great. So I will pip install psychopg2. So I believe you saw this the other day as Zainab was doing a demo using psychopg2. So this is going to be a little bit different from that in that I'm not going to actually call this library myself. I'm not going to import it anywhere in my Python code. It's just that Django-ORM depends on it under the hood. So I'm going to get errors if I don't install this. But after I've installed it, I don't actually have to think about psychopg2 specifically by itself. I'm just thinking at a higher level about Django-ORM. So that's great. I installed psychopg2. So next thing I'm going to do is go to my settings.py in my school project and update the database settings. So we might have scrolled past this before. But today, we're actually going to be modifying them. And by the way, please ask many questions in this lecture if there's anything you're confused about or curious about. It's probably not going to take a ton of time to get through all of today's content, but I think this is really important material to understand fully and correctly, because you don't want to mess up your data, especially on a live production application with users and other developers and whatnot. So they don't actually have any apps yet, so I'll leave that blank. Here we go, databases. So I'm going to edit this a little bit. The default database is SQLite. Not that this is the best choice, but it's the simplest one. It'll work without any other configuration. So I guess that's why it's the default, but it's not what we want to use. We're going to be using Postgres. So here, the engine, you set Django DB backends PostgreSQL. And then for the name, we're going to set that to the name of our database that we just created, which was school. So now we're telling Django, instead of the default SQLite database, you're going to connect to a PostgreSQL database called school. Now, in this case, it's able to connect using just all of the default settings. Like I don't have to change the default port or the default user that it connects as. But in other situations, I might have to like specify other information here to connect. But in this case, this is a simple enough situation. So all I need is the database name.
So I was trying to keep up with the coding and I wasn't able to go as fast as you. So I just want to confirm the only thing different you've done as far as like just setting up Django is that you installed that, what was that thing called? The sidecob thing. And then you updated this database thing. That's the only difference so far, right?
Yeah, I installed psychopg2 with pip, and I updated the database to be PostgreSQL and with our database name. And then also I created this database in pSQL, but that's not something I did in Django.
Okay, so that's the database name, not the project name.
Correct. So
Okay.
yeah, the project is school project, but for the database, I just called it school.
So would it have made a difference if you created the database in pSQL first and then Django, or it doesn't matter?
What matters is that this database exists before Django tries to connect to it.
Okay.
So far, I haven't run my server, so it hasn't actually checked if this database is here. If I tried to like actually run the application before creating this database, then I would get errors at the command line saying that I'm trying to connect to something that doesn't exist.
Can you show me your code where you created that database?
All I did was create database school, just plain old SQL. Dalton, do you have a question?
Yeah, I'm just curious. So since you just said that you have to have that database in there first, is there no way to allow users to like, I don't know if it makes sense to say create their own database, but that's kind of the concept I mean, for like storing different values to their account.
Right, so you would not do that. You would use one database for the entire application for all of your users. Sometimes what you can do is use a different schema for different users. So I'm going to apologize because this is one of those times when programming becomes hard to talk about because one word has multiple meanings. I forget if this was mentioned the other day, but so in a general sense, a schema, when we're talking about databases, is what tables you've got, what types of columns are in those tables, and how those tables relate to each other. That's a schema. But also in Postgres, the word schema has a different meaning, where a schema is like, it's like a namespace for tables or like a folder that you can put other tables in. So like by default, there's one schema in Postgres called public, and all the tables that you create by default are part of the public schema. So like if you create a table called products, what you're really doing is creating a table public.products. But since public is the default schema, and oftentimes it's the only schema, you generally don't need to specify it. So all the tables you create are added to the public schema and you don't have to think about it. But I've seen some, schemes for database organization where like every user will get its own schema or every organization in the database will get its own schema. And that's just to further segregate the data or something. I'm not exactly sure what problem that solves, but some people do that.
So essentially, as opposed to creating a database for users, you would just create their own table essentially, and then they would put everything that's on their account on their own table.
So a schema is like a set of tables. So you could maybe say like for each user, or well, so no, let's say it's like for each organization. So like Code Platoon, signs up for GitHub, and then we have a bunch of people within our organization.
Oh, okay.
Then maybe GitHub would create a schema that's like Code Platoon, and then within that schema, there would be Code Platoon.users, Code Platoon.repos, Code Platoon.other stuff. I don't know. But so that way we have like the same tables as every other organization in GitHub, but it's kind of segregated into our own schema.
Thank you.
Yeah, which again, I'm not exactly sure why you would do that, but I've definitely seen and heard about people doing that before. Yeah, okay. So where are we now? Let's create an app if there aren't any more questions right now. I'm gonna go into my school project. I mean, I'm already in the outer project. Okay, I was already where I wanted to be. So from here, we're gonna Python manage.py, start an application. It's gonna be my attendance app. It's for keeping track of students' attendance. So now that I've created the app, I can add that to my apps in the settings. And now in the app, next thing I'm going to do is create a model. Or, well, actually, no, actually, before I do that, there's something else I want to show you. So first, let's just try to run the application. Excuse me. Okay, cool. So it looks like the app is running. Let's go to localhost 8000. Amazing. It's the Django hello. But now let's pay attention to this message here. You have 18 unapplied migrations. So a migration is basically changes to the database schema. So it's maybe hard to understand why this is important when we're just learning and developing on our local machines. But let's try to imagine a little further in the future. If you're maintaining like an already published application, it's been live for a couple of years, you've got users, you've got user data, they're paying for it monthly maybe or yearly or something. Normally, like if you need to change the schema, well, I won't say normally, but like for us as we're learning now, if we need to change the schema, we might just drop the database and then recreate it with the new schema that we want. But like obviously, if you have a live running application, you can't do that. You can't just drop all your users' data because then you're going to go out of business. There's like nothing for the users to do on your site. They don't have all of their historical data and they're just going to cancel their subscriptions. So that's like completely unacceptable to lose the user's data or to make your database inaccessible for like any amount of time. So what a migration is it's a script that changes the database from the previous version to the next version. So it doesn't like set up the database completely from scratch, just takes it from the previous version to the next version. And then if you need to change the database schema again, you'll just create another migration script, which changes it from that previous version to the next version. So then if you had a fresh database that you need to get up to date, you just run all of the migration scripts in order. So let's see, this migrations folder is only going to show the ones that I've written. So that's why it's empty right now. But Django actually does come with some default migrations to kind of set up the initial database state. So even before I've defined any of my own database models, Django comes with a lot of built-in data. So before I even define any of my own tables, my own models, I'm going to just run the built-in migrations and see what that gets us. So the command for that is migrate. That's going to run the built-in migrations. So there's like, I don't know, a dozen of them or so. But it looks like it was successful. So if I want to understand a little bit better what this did, I can look in my database. So I'm going to use pSQL and access the school database. Cool, so I'm connected. Type \D to describe, see what tables I've got. We're going to make this a little simpler. I'm going to do DT just to see only tables. So you might notice now that we've got kind of a lot of information here already, even though we haven't defined any of our own data. And that's because some of the built-in apps in Django have required data associated with them. So for example, let's look in the settings.py. I added the attendance app, but by default, Django already comes with admin, auth, and sessions apps. And so we can see here that there's already a bunch of tables that look like they're related to that. So like Django session is managing data for the sessions app. All of these tables here, auth group, auth permissions, auth user, those are managing data for the auth app. And pretty sure this is related somehow to the Django admin app. But my point is that the tables in our database are specific to each individual app. And so they're going to have prefixes on them that indicate which app they belong to. So now that we've seen some of these default apps and we kind of know what it looks like before we've actually done anything, let's do something. So in order to create our own database tables, we define that in models. So fortunately, this file is already created for you. And note that the project does not have a models file. The app does. Models are supposed to be specific to individual apps. And the way we define a model is we just create a class in Python. But now all of our models are going to inherit from models.model. So there's this base class in Django just called model, which all of the models that we create will inherit from. So the purpose here is that the Django models come with a whole lot of built-in functionality for how you can like query your data and update it and convert it into different formats. They're very useful. And we don't want to define all that functionality ourselves. We just want to define the few bits of information that are specific to our database tables, specific to our application, and not just like generic Django-ORM functionality. So by inheriting, we can specify only the details that are specific to our student model, and then we can still leverage all the default functionality from models.model. So commonly, like as a professional web developer, this is how you're going to use inheritance. It's not that you have to like define the world and say like, okay, a dog is a type of animal and a Saint Bernard is a type of dog. Like most of the time, if you use inheritance as a professional, it's because you're trying to customize the functionality that some framework is providing you. And this is how you do that. And then the way we actually define our class is, oddly enough, we're not actually going to create an init method. We're not going to define instance variables the normal way. The way we do that is actually just with these like class variables, but these are intended to apply to the individual student records. So they need to have a name field. That's going to be models.chair field. And then we can add a property for that. Max length 200. And they should also have an email address. And that's going to be a similar constraint. It's going to be string characters, maximum length of 200 characters.
Are you deciding, you almost made it sound like we had to have these things. Are you just deciding properties right now for your app, or are these required anytime you use Django-ORM?
This here is how I define the table schema. So like what you would do in SQL with, create table student, and then forget all the syntax, but like varchar name, varchar email, that kind of thing. We're basically defining that same thing, but using Python instead of SQL. So
Gotcha.
for every table you have, you're going to define a model, and you're going to define a property or like a field for every column of that table. So here I've just defined my model, but just defining a model doesn't immediately change your database. So Django ORM does a lot of stuff for you automatically. It doesn't do everything for you automatically, and that's honestly probably a good thing. So just defining this model and then saving my application doesn't actually change the database, and that's good. We wouldn't want the database to just change so easily. Like maybe there's just a typo in my model and then I save, and that like corrupts all the data in my database. That's not what we would want. So there's like a multi-step process, which is still saving you a lot of effort compared to not using the ORM. So the next thing I'm going to do is make migrations. And in theory, you can specify which app you want to make migrations for, but I'm going to do it for all of them because I only have one. Cool. So migrations for attendance app. Now, just for a nice little sanity check, it kind of tells you what the difference is in that migration, what the changes from that version based on from the previous one. And we have created a model called student. Great. That's roughly what I was expecting to happen. And now if we look in the migrations folder, we can see that I've got a new file here, 0001 initial.py. So this is not actual raw SQL, but it's more or less the same thing. This is going to call functions in Django that under the hood run raw SQL code, but it's still the same intention. This is a script that is going to change your database schema somehow. So it's going to create a table. It's going to have these fields in it. And I want you to notice also that this is numbered 0001, because as I create more migrations, it's just going to increment that number. So that way, if I have like a fresh database that I need to get up to date, then we just have to run the migration skips in, we have to run the migration scripts in numerical order. And like, that's the correct order to run them in. We don't have to keep them, like we don't have to keep track of the order any other way because they're just numbered sequentially. So yeah, I also want to point out that like if you're not using an ORM, migrations are still an essential thing to write and to use, but you would have to write them yourself by hand. And you would have to make sure that the migration script that you write matches up with your model. So I just hope that we all can really appreciate all the effort that Django ORM is saving us here, because it's really a huge pain in the butt to write these manually. Dalton?
So when you run the make migrations, that's not creating a table, correct? You would still have to run something else?
Correct.
Or-
Correct. Yeah. Running make migrations just makes this script, and it just dumps this file in this folder, but it doesn't execute the script, and therefore it doesn't have any effect on the database. Not yet.
Thank you.
So even if you just wanted to change, like, because you're not just going to do this just when you make like an entirely new table. If you wanted to edit one of the values, say you decided you wanted to keep first and last name separately, you would make a new migration to delete the name column and then add first name and last name.
Correct.
And then you'd have to go in and like somehow change all of your records.
Yeah, that would be part of the migration, is in addition to adding columns for first name and last name, you would also copy the name. You would split the name into two parts and then copy the first name into one column, the last name into the other column, and then delete the first column. So yeah, a migration can, in addition to changing the schema, change your data so that it's consistent with the new schema.
Yeah, that's a great question, Alicia. And it touches on, Raphael, just like you were saying, like once we have like actual data in our database that's real, that it's in a production environment, then there are like additional considerations when we change things to make sure that all the data is still good.
And a really important part of what you said there, Alicia, was that when there are changes to your database in the future, you make a new migration. You do not ever, under any circumstances, edit your old migration files. Like if sometime in like the middle of the development of like an application, you make some horrible mistake and you're like really embarrassed about it, like too bad, you cannot go and edit that migration. You just have to make a new one that fixes it and gets the database into the actual state it's supposed to be in. And you will just forever have that historical wart in your repo that people can see like, oops, we made a mistake with our database schema way back when, and then we fixed it. But of course, no one's going to actually read them, so it doesn't really matter. But my point is that you never modify old migration files. Dan?
Yeah, can you roll back to your models.py? I lost. So is this like 0001 underscore initial? Has that been tied to the school database at all yet? Have we like tied that migration to the database at all? Like have we assigned that migration to take place on the school database?
So it's funny, I don't think this script itself actually specifies what database it operates on. It just specifies the student table. And then in the settings, we've specified that everything that this application does is on the school database.
Got it. Okay. Thanks. Yeah. Thanks.
Any other questions? See there's a little activity in the chat.
Haley had a good question in the chat about should you put all your classes into one models.py file typically?
That's a good question. It does seem to be like kind of the default suggested organization in Django because they just give you this one file, models.py. I think also Django is kind of intending for you to organize your project into more than one app. So if you do that, each app has its own models.py file. So you are splitting up all the models for your project into multiple files. But I mean, you could also create like a models folder and then like have a models file that just imports all of your individual models and then exports them elsewhere. So I mean, I don't know, I guess this is just a suggestion to have a single models file. If I had a lot of models and they were very complicated, I might find a way to split them into multiple files.
That's what I was about to say. When I've worked with Ruby on Rails, which is in many ways very similar to Django. Also, the models were pretty complicated at the company I was working at. And so we had a different file for each model. But especially for our projects and for smaller models that aren't more complicated, I agree with you, Raphael. It can make organization a lot more straightforward to have it all in one file until that file starts to become unmanageable.
Yeah. Honestly, that's my answer to pretty much any question about organization, that like, it's hard to know how best to organize things until you've got too much stuff and you need to organize it. And at that point, it'll be more obvious how best to organize it. So when a project is really small and you've just got like 2 functions, it almost doesn't matter where you put them. But then as things get bigger and harder to work with, because you've got 1,000 functions in one file or 1,000 files in one folder, then maybe you should consider reorganizing that thing. But like, different projects are going to have different needs. Like one project might have 100 models and 2 routes. Another project might have 100 routes and 2 models. So those different projects would organize themselves differently based on what it is that they have a lot of. All right. So I've been talking a lot about these migrations. Let's actually run them. Let's see what this does.
Oh, FYI, Dan, did you have a question?
Oh, I'm sorry. Yeah, I just missed you.
Yeah. So theoretically, like an app could pull from pull data from multiple databases, right? Like that's something that could be
I
done.
don't think so, actually, because we have to specify one database in the settings.py. So I believe this entire
Okay.
project and all the apps in this project can only use this one database.
Okay, that answers the follow-up. Thanks.
But I mean, one database can still have multiple schemas, and each schema can have multiple tables. So still lots of ways to organize your data within that one database. All right, so we're going to migrate. So it applied the attendance app 001 initial migration. It is okay, so that's cool. So let's get back into pSQL, see what we can see. So now I'm going to do DT again. And so now there are, well, there's really only one extra row that's been added. So at the very top, we have the attendance app student. So you can see here how Django names your tables based on your model. So I was saying before that all of these tables are specific to the app, and the app that this model belongs to is attendance app. And the name of the class is student. So it creates a table called attendance app student. Now there's also some other differences, like it uses lowercase s instead of capital S. And that's just because, you know, the convention for Python classes is to start with a capital letter, but the convention for SQL table names is to use all lowercase letters. So this is just another one of the joys of programming, when you have one word that you have to use in multiple different languages, but those different languages have different conventions for capitalization and spacing. And so you write the same word in like slightly different formats depending on where it's written. So yeah, student as a table name, it's going to be lowercase. Student as a class, it's going to be capitalized. You're just going to have to kind of intuit and internalize these conventions over time.
So Raphael, the table was not in the database until you did that migrate command. Is that correct?
Correct.
Okay.
Yeah, running migrate, Python manage.py migrate, that is what actually executed this script and actually impacted the database, changed my schema. So actually, before I look at the attendance app student, I'm going to look at Django migrations. So that's the schema for that table. Let's just select all the records. So this table, Django Migrations, this was also created by default. I didn't make this. This table is managed automatically by Django to keep track of which migrations have already been run. So, you know, if I run 4 migrations and then I'm collaborating with someone who writes 2 more migrations to update the database schema, then I pull in their changes. Postgres can know internally that, okay, the first 4 migrations have already been run. It's just these other 2 that are new. So I'm gonna, you know, run them from oldest to newest, starting with the first one that hasn't been run already. So, you know, it's got the name of the migration file and then also the timestamp for when it was ran. So this is the only way that Django knows which migrations have already been run before. If you were to drop this table, then Django would assume you haven't run any of the migrations and it'll start from the 001 initial all over again, which sometimes can be useful for debugging if you get your database into a weird state. But in theory, you should never have to touch this table yourself. This is just internally managed by Django. All right, but so more exciting, we want to look at our attendance app student table. So it's got a few fields here. So it's got the name and email, and these are varchar columns, max length of 200. So that corresponds to models.char field, max length 200. But you'll note that there's also another field that we did not include in our model called ID. So this is just one of the many useful things that an ORM does for you. It'll make a lot of intelligent assumptions about how you want your tables to look. Because like for proper database design, there are kind of like a lot of little things that you should always do. And it can be hard just to remember them all, just because there's so many little things. And so one of them is, every table in your database needs an ID column. Sometimes it's not obviously important, but like in the future, if you don't have it, you're going to really wish that every record had a unique ID. So it's generally good practice for every single table to have an ID column. And it's really nice that Django does that for you automatically. If you want, it's possible to configure this behavior. There are like extra options you can pass into Django-ORM to make it not create an ID column, or you can call this something else. And sometimes I do that. There are reasons why integer IDs are not always desirable. But for a lot of common cases, this is absolutely just fine. And so the fact that Django does this for you automatically is great. So as much as possible, Django gives you like a really functional database without you having to specify every single little thing. Again, I see there are a few questions in chat. If anyone wants to actually say a question out loud, I'm happy to talk about whatever as we're doing this. But if not, we'll continue.
I got a question.
Sure.
So we have models.char field, and char field is the same thing as SQL's varchar.
Mhm.
Is there, I mean, oh, sorry. And then also in the table we have, it was automatically made into not null. Do we change that setting, the not null setting, in the class that we're creating, or is that something we do somewhere else?
It's probably here somewhere.
Okay. And then as far as the, do you guys like have a handy dandy like translational chart between, like what varchar is, what we would say in Django, or is that just something you pick up from experience?
It's not a one-to-one. Because like how we store something in the database, like there might be cases where we're dealing with a number that's an integer in Django, and for some reason we want to store it as a string in our database, so that might be unlikely. Sometimes you want to store a date as like text in the database to give you flexibility in the format, but in our Django application, maybe we have like a date type or something in the code. So it's not quite like a direct one-to-one mapping, if that makes sense.
Yeah.
Yeah, no, that's a good question. For Postgres, what I've heard is kind of use the text property by default. I've read that in a couple places for, like if you're looking at varchar and things like that. I think varchar is more of like you have a very, if it's going to be small.
So I didn't remember offhand how to create not null columns with Django-ORM, so I just Googled it real quick. It's just another option you can pass in here. So now if I want to see this change take effect, I will again make migrations. So now I've got 0002 student favorite color.py. and then we migrate. And now let's get back into pSQL. And so in addition to ID, name, and email, which cannot be null, we now have favorite color, which potentially can be null. So it's, you know, a more Pythonic style for setting the SQL options.
So it looks like you don't have to create a new model every time. You just have to update it on the migrations page.
Well, yeah, because it's the same model. It's just my student model. I just added one new field to it.
Okay.
So under the hood, this is running some SQL like alter table, student, add column, favorite color, varchar.
We
200,
would
something
have
like that.
to, Raphael, am I correct in thinking we would have to rerun that migration in order for the change in our model to be applied to the database?
Yeah, I just did that real quick.
Gotcha.
Might have been kind of sneaky.
So, but we would
No, I
never,
missed it. Thank you.
that line that you just showed about the alter table, we're assuming that now using the ORM, we would never type that out, right? We would just create a new migration.
Right, you would never type that out. I'm just trying to help you understand what the migration is doing when you run it.
Yeah, I just
Like,
wanted to make sure that
yeah.
I understood that.
Definitely good to clarify. But yeah, I think that bears repeating that even though using an ORM saves you from writing raw SQL, like we're gonna, you know, be mostly just writing Python code from now on instead of writing raw SQL. It saves you labor, but it does not save you understanding. You still need to know SQL. You need to know what you're expecting the ORM to do, because sometimes it's not going to do what you expect it to do. And you're going to have to look at the raw SQL that it generates and ask yourself, is this what I'm trying to do right now? And if it's not, then you'll change your code in Python with the ORM to make it do something different to the SQL database. But if you don't actually know SQL and you don't actually have expectations about what SQL the ORM is supposed to create, it's very hard to debug when your application isn't behaving the way you think it should.
And am I correct that the -- plan flag to the migrate command shows us some of the SQL or commands that the migration is going to execute?
I don't know about that.
I had to Google it. I was just Googling it a minute ago because I was familiar with that feature from Ruby's or Ruby on Rails' migration tool. And it looks like it's similar with Django, but I haven't really used it.
Wait, was it plan or planned?
PLAN, sorry.
Oh,
It would be, I think, in the migrations. Yeah, if you, yeah.
not documented here.
Let me, here, I'll throw the link in the chat. If you search for -- plan in there, it should come up.
Okay, so instead of Googling, another good way to find information about commands is just asking your command line. So for all these Django-ORM commands, or for all the Django commands, you can type -- help after any of them and it'll tell you how they work. So I just did Python manage.pymigrate -- help. It's telling me we have optional arguments, -- plan. Shows a list of migration actions that will be performed. So I'm assuming that this means it does that instead of actually performing the migration.
That is correct. That's how the Ruby on Rails one worked.
So I feel like I've heard of things like that in other contexts as like a dry run.
Yeah, that I think so.
Okay, so no
and
planned operations.
Because maybe because they've all been applied.
Yeah, so let's change this to max length 199 instead of 200. Then we're gonna make migrations. So it tells me in English what it's going to do. I'm not sure how incredibly
Yeah,
useful that
I
is.
would have expected, yeah, I would have expected to, and was familiar where you actually saw the SQL that it was going to execute.
Yeah, and
Maybe
there's
there's
gotta be
like
a way to get that.
yeah, maybe it's like dash dash plan dash dash verbose. Can we do help on plan? I don't know. I'm gonna Google. And I don't want to open up too much of a tangent. If it had shown us the SQL, that was what I wanted to share, because I know that's helped me a lot in the past.
Yeah, I'm not sure how to do it offhand, but it's definitely an important thing to know is how to get your ORM to show you the raw SQL for what it's doing. But oh well.
Looks like there's a -v flag you can use and then pass it like an argument there.
We can see what that does.
That would be awesome.
Do maximum verbosity. That's still a little disappointing.
Can we use that on the dash dash plan? Like add that to that?
Oh,
That's a good question.
so make migrations. And then dash dash plan. Verbosity level 3. Yeah, it doesn't give us much.
I did find something that prints the SQL for the named migration, but it's part of Django admin. It's not even part of the migrate tool per se. So I will do a little research over lunch, and if I find something good, I'll share it with everyone.
Yeah, let's come back to that. So the next thing I want to show you is we're just going to insert some data into our database. So normally you would do this like through a view. You know, a user is requesting some URL on your site, like create users or whatever. And then you have a view function that is going to actually like contact the models. But just for the sake of time, so you don't have to watch me build out like an entire Django application right now, I'm going to show you the Django Shell, which lets me use the command line to write Python to interact with our database. So this is the same kind of code that you'll write from inside your applications. Just for ease of explanation, we're doing this at the command line. So type Python manage.py.
As opposed to in the views folder.
Right. Normally, like in the views, or I'm sorry, in your views file, where you have all the different functions for your route handlers, usually that's where you would put this kind of logic. Like in response to someone sending you a request, you're going to query your database.
Okay.
All right, so I got the shell here, Python manage.py shell. Now I can actually import my models. So we're going to say from I think there's a typo in the notes. Should be from attendance app.models. So attendance app is my app. Models.py is a module inside of it. And then student is the class that I'm exporting from models. Cool. So now I have access to student, this student class that's been defined in my models. And so now I can use it basically like any other OOP class in Python. Say new student equals student. We call our class and we pass in named parameters. Name is John. Email is john@john.com. And then, so that creates a student in Python in Django. Now, in order to actually save it in our database, we have to call new student.save. So that actually puts it into our database. The reason why it doesn't happen immediately is because we might want to edit the student. So figure like in SQL, you can describe a whole bunch of changes to something in one SQL statement. Whereas in Python, we would probably define a bunch of changes to an object over multiple lines of code. So Django doesn't want to actually run SQL commands every time you do anything to this student. Like, if I wanted to say new student.name equals Tom, Django doesn't want to query the database immediately when I made this tiny change, because I might make a bunch of other small changes too. So essentially Django is like batching all these changes together, and then it doesn't actually query the database until I call save. So let's actually take a look in pSQL again. Cool. So we've got john@john.com. Even though I just set new student.name as Tom, so I have to save the new student. We go back to pSQL. And now John's name has been changed to Tom. Didn't update his email address though.
Okay, so it sounds like if you're changing a table attribute or column name, you would have to write a migration for it. If you're changing a value in the table, it's just like Python, you would just reassign the value.
Right.
And kind of related to this, like when we're working on our personal projects or exercises and stuff, and we need to interact and play with the database, would you recommend doing it through the pSQL tool or through that sort of ORM Django console that you were sharing?
I actually never used the Django console outside of this demo right here. My preference would be to write a SQL script and then plug that into pSQL. If like all you had to do was change some data or something.
Got it. Thank you. That's really good to know. With Ruby, I would use the console a lot, but that's a different, like there's a lot of small differences that add up. So that's really good to know, like what's been working for you. And that makes sense too, because with the SQL, you can see exactly what's going on in the database.
Yeah. I mean, also I've been writing SQL for years and I've been using Django-ORM for comparatively less time, but I just feel like, I don't know, the SQL is clear and unambiguous. Like I always know what it's doing. Whereas, with the Django-ORM, you have to keep in mind how these classes and objects map onto your database tables. There's that extra layer of translation. So if I'm actually like directly modifying the data with a script or whatever, I might want to look at the actual raw data just to make sure I know what I'm doing.
That makes sense. And that actually raises a good point. We can do really powerful stuff with the Django ORM and with our Django models. That's what I've seen like when I worked at Reverb, there was a lot of Ruby on Rails code and with some very sophisticated models, and that made sense for that situation. I think especially for learning, and I'm curious what your takes are on this are, Raphael and Zainab. It will probably make sense to keep our models like relatively simple without too much logic in the beginning, at least.
I would agree with that. Django does let you put lots of logic in your models. Like you can define functions or like other methods for these classes in addition to just the data. I try to do that as little as possible. Generally, I think the logic for your application should live elsewhere, like in your views. I like the models to be just as simple as possible, just a definition of your data. Dalton?
Cool, thank you.
Yeah, I just want to go back to actually writing the model itself. So when you say it's by default, if we were to create the ID column, is that going to create a duplicate, or is it just not going to do it anymore?
I don't know, let's find out.
And I guess I want to ask also, is it common to just let it do it by itself, or would you probably prefer to actually be specific about creating the ID?
In general, I like to rely on the defaults as much as possible. Just because like the database is, the ORM is doing so much for you by default. And I assume most of it is clever and correct. And so I just let it do its thing. And it just reduces the amount of code I have to write. So that way, like understanding the application is more about understanding how Django ORM works and not reading every line of code that someone else has written before me. Sorry, can you repeat the question?
Just like, so like, say, like if you're going to make that teacher, say you said ID equals, I'm not sure how you do like the serial key because it said big int, but like, would it create a duplicate where now you have an ID and it also creates another ID, or?
Let's see, so models integer field. And then let's go to the name. So we make what? Interesting. So they don't let you make a generic ID field, but they will let you overwrite the default primary key. Like you can override the ID with your own ID as long as that one is also a primary key. You can't just like make some random ID field that is not the primary key. So that's kind of funny.
So it probably sounds like then you might as well at this point just let it do it by itself.
Yeah, that's a fine option. So then if we p-SQL school. Oh, by the way, there isn't like really any more content for this lecture today, so just like ask all your questions. I guess I'm not really sure what I was expecting. Okay, so yeah, here we have an integer ID, whereas by default it uses the big int ID, which also has like the default like serial thing built in. So the IDs will automatically increment as we create new students. Whereas for the teachers, because it's just a regular integer, these don't increment automatically. So I would have to manually set the ID for every new teacher I create.
Good to know. Thank you.
So I think I might have mentioned this before, but honestly, I wouldn't think too hard about the IDs in your application, about like these integer IDs, because practically speaking, you're probably not going to be using integer IDs. You will instead be using UUIDs, is what they are called. Yeah, so something like this. So a UUID is used as an ID, but instead of just being an integer, it's like a very long string. And the UU stands for universally unique. For a variety of reasons, it's apparently impossible for the same UUID to be generated twice. Like there are various bits of information that are incorporated into this UUID, including the time when it's generated and identifying information about the machine that generated it. So apparently you have a guarantee that even if you have two different machines generating UUIDs like in different time zones or whatever, there's no way that they'll produce duplicate IDs. So this has a few advantages. For one thing, if you like have multiple different databases that need to synchronize with each other, you need to make sure that you don't create duplicate IDs, where if they both are just using serial integer IDs starting at 1 or whatever, then they're going to end up with a lot of the same ID numbers. So being universally unique is super useful. It also means that your IDs are not guessable. So if someone is like trying to hack your system or whatever, and they see like they look in the network tab and they see like, oh, when I logged in, it sent me the user data for user number 502. I wonder if there's a user number 503. And so if other parts of their security are not bulletproof, like being able to guess a user's ID number kind of gets you one step closer to accessing information that you shouldn't be able to access. But if all of your user IDs are UUIDs like this format, there's really no way that someone can guess another user's ID just by knowing their own. So the unfortunate thing is that you have to generate these manually. You can't rely on the ORM to create them automatically, but it's really not so bad. Okay, so yeah, it's just another one of the types built into Django ORM. You can just say I'm making an ID and it's going to be a UUID field. Oh, actually, maybe Django can generate these for you automatically. I'm going to do that. Let's see what happens. So we make a class for this is the school administrators. So they're going to have like even better security. Do I have to import UUID? And there are multiple different versions of UUIDs. For some reason, everyone uses UUID v4. I don't know what the difference is. Maybe that's just the most modern one. So we'll exit. We'll make migrations. We will migrate. And then I'm going to try to access the shell.
Can you explain while you're doing this when you want to access the shell? Like, is there, like, I kind of get the concept, but.
Just because I want to insert some data really quickly without building out a full Django application. Normally, like someone would submit a form on the front end and that would send a request to a view, and that would query the database and then do what was requested and send a response to the user. And that's just a lot more work, and it's not really the focus of today's lecture. So I'm kind of taking this backdoor shortcut here and just directly inserting data into my database. But I wanted to do it with the Python syntax instead of the SQL syntax. And in theory, doesn't need any arguments because it has just the ID field, which should be applied automatically. We save. Let's just say admin2 is administrator, and then we will save this guy.
Did you have to import something for the UUID?
Yeah, so it's available by default in Python apparently, but it's not like always accessible. So I had to import it, but I did not install it.
Okay.
Then if we go over here, pSQL school, look at the attendance app administrator. Cool. So yeah, in this case, Django-ORM has automatically generated UUIDs for my administrators because we said that the type is a UUID field and it has a default value. I believe this is a function that just generates UUIDs. So it's saying if I try to create a new administrator and I don't pass in a specific UUID, it's going to just run this function, and then whatever it returns, it uses that as the default value.
So with that, if you're using that as a foreign key, are you just going to have to copy and paste straight out of the terminal into wherever you're going to paste it? Or is there some type of function that you can use to grab that ID and put it as a foreign ID for another data type?
I mean, you're always going to be referring to things by reference. Like, you know, we'll have objects in Python and we can just refer to like, just admin.id or whatever, you know? So you don't really have to be concerned with the fact that this is a big ugly string because you're never actually looking at it. You just have variable references to it that you can pass around.
Okay, thank you.
Yep. What other questions do we have?
I had a question about the make migrations and migrate.
Yep.
So so the make migrations creates that script that we should never touch, right?
Yep.
Okay,
These guys.
and then the migrate actually runs the scripts, and the end result is we get a table.
Yep.
So normally we would just, right after we do make migrations, we immediately just migrate. Is that correct?
Yep.
Okay. Is there any, like, so for example, if we did the make migration step and then we realized suddenly that we screwed up, would it be wrong to go ahead and make a change and then make migrations again and then migrate, or is that going to screw things up?
Where's it hurt? Show me.
So
The only thing wrong with you is that your hands are dirty.
hang on a second.
Yeah. You
Uh,
wash your hands?
I think there might be a hot mic in the
No.
Yeah,
class.
can you mute Maya for me? I'm not logged in as a host.
I don't know if I can do that while I'm screen sharing.
Can you make me host? Hey Maya, your mic's hot, just FYI.
Oh, sorry.
Oh wait,
No,
actually I can do it.
no
Never
problem.
mind. You're right. Anyways, sorry, what was I saying here?
So if you've done the make migrations, but then you saw that you made a mistake in your,
That's right.
yeah. Okay.
So if you're saying you made the migrations, but you've not yet run it, in that case, I might actually just delete the migration file and then make migrations again. I think that's how I would do it. So let's see here. let's see, I make a new class called mistake. And then I make migrations. So that gives me this file called mistake. But if I have not yet executed it yet, and I change this to correct. So yeah, I think I would just pretend like this file never existed. See if I delete it. And then if I make migrations again. Okay, yeah, and then this guy is 0007. So it looks like Django recognizes that that migration was never run and is willing to pretend it never existed.
Okay,
And then
thank
I
you.
can, oh wait, I already did that. Then we migrate. And so now we should have the correct table. Yep. And we do not have a mistake table. Cool. So yeah, what other questions have we got?
I have a question about SQL. It's not directly related to ORM, if that's okay.
Yeah, go for it.
So I think like 2 days ago when I was working on one of the assignments, if I remember correctly, I believe I got it to work using foreign keys, but when I was looking at the notes that I believe Adam did in class, he was just using references, but he wasn't putting foreign key in front of it. And I was just kind of curious as to like, is there a difference there? Is it just something like syntactical or?
So there are a few ways to set up those foreign keys in your SQL tables. I'll say one thing that makes a difference is if you're setting up a foreign key relationship in a new table as you're creating it, or if you're adding that foreign key relationship to an existing table that you've already made. So you might use different options depending on which circumstance you're in.
Okay, that makes sense. Because I was trying to create them all at the same time and I was only using references and I don't think it was working. But if I deleted the database and I added foreign keys, I believe that's when I got it to work. So does that sound like it would make sense?
Makes sense.
Thank you.
Yep. Any other questions? No.
This might be a little off the wall, but I saw that there's a blank thing that you can use instead of null or not null. What exactly is the blank for, and like what's the preference over blank over null?
So that is a good question and is a little bit tricky to answer. Because blank is not quite the same as null. So let's see. When I said like null equals true or whatever, this is changing settings on the SQL table itself. This is basically whether or not this is not null in this column. Blank is not actually about the SQL itself, but about how Django will talk to your SQL. If you set blank equals true, then that means that in a form where someone is like for example, for the student class, if we had a registration form where students are signing up, we could set blank equals true to indicate that the favorite color can be empty in the form that they submit. But maybe we could have like null equals false to indicate that like there needs to be a default value that Django sets, but the user doesn't have to type anything into the form. So like, I guess blank equals true or false is kind of like a step before null equals true. Like when you're getting input from the user, can they omit that particular field? But that's a separate consideration from when we put this into the database, can we omit that particular field? Hope that helps. Let me think here.
I think I may be able to understand it. Thank you.
Uh-huh.
We at some point see an example of now using the ORM to, or maybe I'm just overthinking this, I wouldn't be surprised, but now using the ORM with a form to go and grab that data and assign it to like a class value and updating the database table with that value.
That would definitely be a great thing to see if we had, if this wasn't already noon. We could possibly come back this afternoon and I could show you that kind of stuff. But actually, let me look at your homework real quick.
There is, I'll share it in the chat. There's sort of a way to view what SQL a migration produces, but it's not great. Like you can view the SQL that a specific migration will produce. Like if this was a file named 0001, just it's a little bit of a tangent. Not something that folks have to worry about.
So it looks like your homework for tonight actually doesn't require you to build an application with Django. You're basically going to be just like writing like the shell commands that I was using before, where whatchamacallit, it's just like Python manage the PyShell, and then I just imported the models and I was typing commands like right here to do whatever. You're not actually going to be using the Django shell, but we're going to have you write tests or complete tests that have already been started. So it's going to be kind of similar to what I showed you, where you're just writing Python code to manipulate these models, but it's not going to be in the context of a full Django application. So it's kind of like a more bite-sized homework is the intention. So while it would certainly be very useful to see how we would hook this all up to a form to query this data, submit new things, whatever, that is actually not the next thing that we need you to do with Django-ORM. So I can still definitely show it to you this afternoon, but you're not going to need it immediately. What do you think? I will figure it out, I guess. I saw another hand up. Dalton, did you have a question?
No, I may have left it up, but I do not.
All right.
I have a quick question. I was wondering, is PsychoPG, is that specific to Postgres, or is that what Django uses to talk to any database?
I believe it's more generic. Or no, actually, I think the PG stands for Postgres. Yeah, okay, this is definitely for Postgres. It's not specific to Django, so you can use PsychoPG in any Python project to communicate with a Postgres database.
Okay, thank you.
Mm-hmm. What other questions have we got this morning?
When it came to in settings PY, when you linked your database, did you erase the database that was already in there? And then just, I see.
Mhm.
And then is there anything else that you need to do to link your database, or was that it?
I mean, I had to create the database at the command line. So Django cannot create this database. I had to do that any other way. So I just used pSQL, create database school, and then I added in here, and that's basically it.
Okay.
For the most part, I'm using like all the default values for Postgres, so I didn't bother creating a new Postgres user, didn't set their password. It's all just the default values.
Got it. Thank you.
Yep. Do we have other questions? Or are we ready for lunch? All right, I think the questions are drying up a little bit, so I'm going to conclude the lecture here.